Hi, I'm Sarah and this is Aaron as introduced. We're from OMX Solutions, so in quite a different track, we're a medical device company and we specialise on customised and in particular 3D printed implants. We specialise in the maxillofacial, so the facial jaw implant space. So here's some of our products. With our products, our engineering team works in conjunction with medical professionals to design customised implants that are optimised to the individual patient. So as you can see here, these are moulded to the anatomy and completely suited to the patient. So we have a suite of products including models and guides as well as implants, and I wanted to focus on two today to just introduce you to a couple. So the first one we have here on the right is the TMJ. So this is the temporomandibular joint. It's the jaw joint, and we create a replacement device similar to a hip or a knee replacement. So this is suitable for people that have severe joint pain, a lot of discomfort, limited mouth opening, can't talk easily, can't eat easily, and so worst case scenario when no other treatment methods work, the surgeon goes in, they actually completely remove the natural joint and replace it with this titanium 3D printed lower component, and the upper component is a socket, so the lower component has a ball and then a polyethylene socket, and it places the joint. Both of these parts are the titanium 3D printed, and the polyethylene part is CNC milled, so we can customise the shape of the internal surfaces to completely mould to the patient's bone. The second product I wanted to introduce you to is the OsseoFrame. Aaron will show you an example of this later. The OsseoFrame is, I'll show you a little video actually. Let's play. This may not work. Yeah, I'll go back to the photo instead. So the OsseoFrame is a titanium frame that sits on either the upper or the lower jawbone. It has these vertical abutments or posts, and it allows for the attachment of permanent dentures like you can see on the top left. So this is really suitable for people who are missing one or two or more teeth, up to even a full mouth of teeth, and they're not eligible for typical dental implants due to significant bone loss due to trauma or whatever else it may be. So we customise these implants to fit perfectly onto the patient's bone. The surgeon implants it into the patient, screws it in, and then the patient's able to have permanent dental implants placed in the same day surgery and walk out of the hospital on the same day with a full mouth of teeth. Oh, here's that video. So as you can see here, the frame is completely moulded to the patient's anatomy. It sits up on the jaw. The surgeon places in some screws to secure the device, and then the tissues close up around that. Luckily, this is an animation, so not too much blood and guts. And then the clinician then places the dentures, as you can see here, up on top of those abutments, and these are screwed into place and securely remain for the rest of the patient's life. The surgical procedure only takes a matter of hours and the patient can go home smiling in the same day. So this is a bit about our design process. So we have the base designs for these products that we've developed and validated, and then for each individual case we have to go through additional design processes. So we receive a CT scan from the clinician, so this includes images in 3 different dimensions, and our engineering team is able to develop a 3-dimensional model of the patient's anatomy. From this model, we're able to design an implant that molds to their anatomy, has the appropriate sizes and shapings as the clinician has prescribed, and then our engineer is able to take this to the surgeon and get their feedback and approval. Often this is a cyclic process, so it goes back and forth between the clinician and the engineering team to get the design that the surgeon's happy with, but is also engineeringly structurally sound, so to speak. Once the surgeon has given their final sign of approval, we manufacture the parts here in New South Wales actually, and then they're sent to the hospital and implanted into the patients. So with this, we sort of have a range of design constraints that we work within for each of the products, and we test the worst case scenarios mechanically or otherwise. Because these are customised to every single patient, unfortunately we can't print out 20 copies of these expensive titanium implants and test 19 of them and then just put one into a patient. So what we've done with the use of ANSYS, which we've just recently got in the last 12 months, is added an additional step. So with this additional step, we're able to test our designs as they evolve, and this also sort of limits the back and forth between the engineer and the clinician. So I'll move over to Aaron now, and Aaron will take you through an example of how we use the simulation software in a little bit more detail.
So don't know who here who have ANSYS, who don't, but part of ANSYS incorporates a material library, and so that covers things like aluminium, stainless steel, and those sort of ones. Our areas of interest is biological. So the good thing that we can use with ANSYS is we can add material properties. So an example we have here is, hopefully I don't break it by using my laser. There we go. So it can tell us bone, cortical bone. So this way we're able to simulate the bone in the body. So this saves us a lot of time because you don't have to try and get cadavers or deal with animal testing. Additionally, we're also able to separate components that have similar materials but at the same time different properties. For example, we have titanium which goes into our implants. Now this is grade 5 titanium, it's an alloy, which means it has different properties than a standard grade 4 titanium which we use for our screws, which is just pure titanium. Which means when we run the simulation, we're actually able to see the different impacts. We can see if the grade 4 titanium suffers more than grade 5, instead of just hoping that the titanium is sent. So in a world, we're able to use it best by simulating a real world scenario. So in this case, I have it set up so everything's about to go forward. So if an osteoframe sits on the top of your mouth or the bottom of your mouth, and in those cases, you experience about 2,700 newtons of force when you bite down. And then when you grind, it's 71 newtons of force side to side. So what we're able to use with ANSYS is we're able to completely mock that up. So as you can see here, we have the forces already applied to the abutments, as well as able to replicate the getting fixed to the bone of the actual skull using surface implant. And then once we have it all set up, we can just run it, which brings us to this slide. And this covers primarily what ANSYS does for us. So you can see in the top one, this is just a deformation simulation. So we're able to see, I'll help you guys on the outside of the room. We can see in this area here, we actually see deformation. And the bottom slide is the stresses and strains to be expected. As you can see here, we can see the expected stress and strains at the top of the abutments. Now this is actually really handy for us because, what it means is when we're designing our device, we can see that it's in these areas where deformation takes place. So these are the areas that we need to reinforce and strengthen. But on the other side of that, we can see there's areas that actually don't suffer that much deformation at all. So we can actually take material away from that, which means the overall price is less, as well as it's a much lighter weight device. Same can be applied with our stress and strain. As a result of this, we're able to modify actual manufacturing procedures so it better suits potential issues. For example, with the potential stress and strain issue, we're able to solve that by heat treating our devices once they're made. Now, on your right-hand side of the screen is some of the actual implants in patients. And so the first two are the TMJs that Sarah covered, and the bottom one is one of our osteoframes. Now, the osteoframe, this one, it's different to the modifications you can see, or the large scale, which means when we're actually making it, it's so different from our old ones. We'd have to run through multiple testing just to see if it's safe. But thanks to ANSYS, we can just chuck it in on bone, fix some screw models, and we know that it's safe. I'll give you a real-world scenario to help set home the point. This patient came in with damage to the condyle, which is part of the upper jawbone or lower jawbone towards the top. And he looks happy here, but what happened was, due to the bone deforming and degrading, he actually hurt to talk, which isn't fun for anyone. So because we were able to implant a TMJ, which was molded to that bone, we're actually able to improve his face, and as a result, improve his quality of life. So primarily what we do with OMX is we make custom devices, which we know improve the quality of life, and thanks to ANSYS, it's much easier because we can save pricing on doing catalyst testing, like Sarah suggested, and we can make it so the device itself is just better. And that's the end of it. Thanks.